Today was the first day of the unit and we learned about the real number system. So in the real number system, you have both irrational numbers and rational numbers. I know in past grades, most of you guys have been working with rational numbers, but in 8th grade, we will be working with a lot of those irrational numbers. So if you have this note sheet, you do need to write the definition of a rational number. So looking right here, a rational number is any number that can be expressed as a fraction. Meaning if you can write the number as a fraction, then it is considered rational. Now, irrational would be any number that cannot be expressed as a fraction. So if there is no way to write that number as a fraction, that means it would be irrational. Now, today the students had a card sort. They were given a bunch of pieces that were cut out of different numbers, and they had to sort them into groups. Now the groups they came up with, there was a variety of them, so they came up with that on their own, but here were the numbers that were given to them. So some students grouped these into groups of integers. They put all the decimals together. Maybe some students put all the roots together, even like cubed roots, squared roots, fractions together. Some groups even separated the positives from the negatives. So that was from today's activity. After we sorted them into groups, we then filled out our graphic organizer, which we are going to do right now. Now, I'm not necessarily going to use the same numbers, but I will still use a few examples for each. So we're going to start with a rational number. So rational number is any number that can be expressed as a fraction. So what that means is that whatever fraction we write down would be considered rational, right? So we could have, let's see, fraction. We could have 1/2. We can have 4/5. We can even have improper fractions, such as 7/4. Okay, so any of those fractions would be considered rational, and they're already in fraction form. Now, if I'm looking at integers, integers are whole numbers and their opposites. So that's kind of like my negatives and my positives. So we can have, let's say, -11, -2, 0, 1, and then maybe 150, right? So those are my integers. I know they are rational because any integer can be written as a fraction because we can really write any of these numbers over 1. Now I'm going to move up and I'm going to look at decimals that end and decimals that repeat because those are a little easier than those perfect squares. So a decimal that would end would be like 0.5, which we know is 5/10 or 1/2, right? That decimal can be written as a fraction. We could also have 3.25. That would be 3 and 25 hundredths. So 3 and 25 over 100. Again, that decimal can be expressed as a fraction. Now, decimals that repeat. We can have 0.3 repeating, okay? That could also be written as a fraction. That is a commonly known fraction as 1/3 is actually 0.3 repeating. We will actually learn later on how to turn these decimals into fractions. Now, something like this. I have 0.2525, okay? That is a repeating decimal because looking at it, I can see that the 2525 is repeating. Okay, so that would be considered a repeating decimal even though it does not have the line above the 25. Now, perfect squares. I'm going to give you an example of a perfect square. One perfect square would be 4. The reason why 4 is a perfect square, because the square root of 4 is 2, meaning 2 times 2 is 4. Now let's think of another one. Square root of 9. What number multiplied by itself would get you 9? Well, 3. 3 times 3 is 9. Another one that would work would be 16, because 4 times 4 is 16. Now let me pick a larger number. 49 would also be a perfect square, because we know 7 times 7 is 49. Now, that kind of goes back now to irrational numbers, and we're going to talk about what is an imperfect square, so the complete opposite. So an imperfect square would be something like square root of 2. Because a number multiplied by itself, you cannot get 2. If you do 1 times 1, you get 1, right? If I do 2 times 2, I get 4, but I cannot get 2. Another imperfect square would be 5. Because what times itself would get 5? That will not work. Let's also write here square root of 23. So again, there is no number multiplied by itself that can get 23. So that would be imperfect. Now, we also have decimals with endless non-repeating digits. So I want a decimal that doesn't end and doesn't repeat. There's actually a very common number we use in geometry is pi. Pi is a non-repeating, non-terminating decimal. That would be 1. I'm going to give you an example. 3.1215. And it keeps going. There is nothing repeating in that, right? It's 3.1215. So therefore, it would be irrational. So just to recap, a rational number is a number that can be expressed as a fraction, and an irrational number is any number that cannot be expressed as a fraction.